over, giving you iron, magnesium and so on. If they could talk to you, they'd tell us an awful lot.
Tell you where we came from.
Yeah.
So you can think of yourself as, if you're romantic, you can think of yourself as stardust. If you're less romantic, you can think of yourself as the nuclear waste of stellar evolution.
We prefer your first suggestion, don't we?
Don't forget that even our sun, a very mild star, I mean, our sun is losing mass at the rate of 4 million tons every second. Therefore, the sun weighs a great deal less now than it did when we came on the air.
Excellent. And Monica, you've got another picture from Hubble?
It's another picture from Hubble. This is much, much closer to home. This is a picture of Mars, showing that the Hubble is taking pictures not just of sort of the dawn of time and the galaxies and stars, but of our own planets, planetary systems. And this is one of the best pictures of Mars that we've got, showing very clearly the north and south polar ice caps and some of the relief on Mars and some of the dust which blows about the planet.
Right, and the other picture you have?
The other picture I have is another neighbour, Saturn, and what this is showing are the aurorae on Saturn, these golden rings at the north and south.
These are very beautiful, aren't they?
They are very, very beautiful. This is the interaction of this stellar wind with the magnetic fields of Saturn.
And that's what's creating that golden look?
Just the bits at the top and bottom of the planet, yeah. The rings, of course, are something completely different.
I'm sure what we've said has given rise to a lot of questions in our audience. So now is your moment. Yes, sir.
Yes. What exactly are black holes, and can we get sucked into them?
Paul?
A black hole is a really massive star, or possibly a really massive collection of stars, and it is so massive that any light that attempts to escape from it can't. It gets dragged down by the gravity of the star. And that means if you're outside that star looking in, any light that it sends you falls back into it. Effectively, you simply can't see it. It's black, therefore. And if you drop into it, even if you drop something into it like a little spacecraft, that spacecraft can't get out either because it's dragged back by gravity. So it's a hole you can drop things in as well.
Point, isn't it, there that if light can't get away, then nothing else can, with light being the fastest thing in the universe.
Absolutely.
And what you said was, can we fall into it, or can we be sucked in? Can we?
Well, if we happen to encounter one, yes, in our voyages through space, then we could drop into one.
But you can't see it, can you?
You would be able to tell that it was there because it's dragging you. Although you can't actually see it, you could perhaps see things falling into it already, things ahead of you that have got there first, and you can certainly feel its tug. And in fact, if you approach it, as it were, feet first, you'll find that the pull on your feet is much larger than the pull on your head. So you'll be stretched into spaghetti, in a process called spaghettification. So you die of being made spaghetti before you die of dropping into the black hole.
I tell you, these astronomers are small boys, isn't it?
But as you're saying, all light or matter is drawn into these black holes. What exactly happens to all that matter? Does it end up someplace else, or does it clump into another mass, or what exactly happens?
Well, it might just sort of feed the black hole so the black hole grows a little bit when you've dropped things into it, like energy or mass. Or that stuff might actually connect through. Some people think, there are speculations that things that you put into a black hole connect through the black hole into other universes that there might be.
That's what I was more...
Connect through into...
Another universe.
Wow, I like that idea.
Through something called a wormhole that connects through to some other parallel Esther show somewhere else.
I like that even more. Thank you very much. Yes, madam.
Yes, I would like to ask you, what is this star they call the morning star and the evening star? Is it really something that exists?
Patrick, what are they?
Venus. The planet Venus, the brightest thing in the sky apart from the sun and moon, it goes around the sun closer in than we do. Therefore, you see it either very brilliantly in the west after sunset or brilliantly in the east before dawn. And at the moment, you can see it just before dawn. You'll see it rising. In point of fact, the evening star and the morning star are the same thing. They are the planet Venus, the old name for it, because in ancient times, they didn't realize they were one and the same, but we know that now. So the answer is Venus.
Thank you.
Thank you very much.
I'd like to know, is there such thing as a white hole? And if so, what part does that play in the universe?
Well, black holes are where energy goes in, and white holes are where it comes out somewhere else, if that's what happens.
Do they exist, or has someone made them up?
Someone made them up.
Oh, fine.
A lot of astronomy is a kind of an imaginative process where you imagine what might happen and then look for places where it has happened, you know. So it's kind of fun.
Right. Yes, madam.
Oh, yeah. What can Hubble tell us about how the universe began?
Well, it can...
Mike.
If I can take that one. It can't tell us yet. None of astronomy can yet tell you how the universe began. All that astronomy has so far been able to find out about that is that the universe came into being, as far as we understand it, in a very special way. For many years there was a theory called the steady state theory, which held sway, which sort of said things were much the same and always looked much the same over time. But it was realized during the 20s and 30s and through the latter part of the last century, sounds funny to say the last century, doesn't it? But anyway, through the last century, that if you look at the way the universe is constructed, you can see that at one time things were much closer together than they are now. The so-called Hubble expansion, you trace that back, things were very close together, very hot, in a very special condition called what we call the Big Bang. And in tracing back our theories of astronomy, I showed you this fine picture a little while ago, if you remember, of distant galaxies. Just go back further and further. You've gone maybe 9/10, 19/20 of the way back to the Big Bang. Keep going. What happens? Well, we don't know just beyond that. There's a sort of dark ages beyond that, which is fascinating to study and is just beginning to be studies about what happened beyond that. Eventually you go back a bit further and you find you're bathed in hot radiation. It's been heating up or cooling down as the galaxy has been, the universe has been expanding, but if we go back, it would look hotter and hotter and hotter. That's radiation left over from the Big Bang. We can see that. We've measured that, the so-called cosmic background radiation. Very good evidence that there was this very early hot phase. Beyond that, we can only trace back by using theories of the way particle physics is put together, the way protons, neutrons, and so on came into existence. We can go back and back and back, and current theory, depends who you believe, of course, is probably fairly reliable to a few seconds after the Big Bang. Some particle theorists will say it's good to a 100th second or a 1,000th second. We can begin to trace stuff back to maybe 1 over something like, I don't know, 30 noughts, 1 and 30 noughts over, that sort of fraction of a second after the Big Bang using current theory. Beyond that, to go back beyond that and trace to before that time, we don't know. Got to build better theories, understand the processes that went on there better, and maybe eventually be able to work out from the way the universe was then and has evolved since that time, what might have preceded that, how what might have gone before that set the way the world is now.
You know what worries me about this one?
Go on, Patrick.
I don't believe we're discussing the origin of the universe at all. The one point is, we exist. We've come from somewhere. Therefore, either the universe has always existed, you've got to imagine then a period of time that has no beginning and you can't do it, or else it was created at one particular moment. What happened before that? There wasn't a before. And therefore, I maintain, we've never discussed that at all, we're discussing the evolution of the universe, starting from something, and I compare that with an intelligent gentleman from Alpha Centauri C, who comes down here and spends half an hour in London to see babies and boys and men and old men. He'll see a baby turn into a boy and a boy into a man, and he'll work out the total evolutionary cycle of a human being. But unless someone's told him the facts of life, he won't know how the baby got there. And in cosmology, our baby is the Big Bang. So the answer is, frankly, I don't believe anyone has a clue.
Well,
Right, yeah.
I can't give you the answer yet, but astronomers are working on it. I think there are clues there. There's an awful lot of work still to be done. We don't know the half of it, let's be honest. But in time, we do know a great deal more than we used to. And if I go to London and watch these men going on, I think I might have a word with one or two of them, or watch them very closely as what they're going into those hotels for and so on. Find something out.
Yes.
You'd have to have a very strange mind, Mike. Yes, sir.
Many astronomers and physicists, certainly in the past, Einstein I'm thinking of particularly, often refer to God. I think Einstein said something like, when you study the universe, you're studying the handwriting of God. I mean, that was his opinion. The beauty of the Hubble photographs and the beauty of the laws of nature, can I ask the panel whether they feel there is something behind it all?
Robin.
I think that you have to be very careful when you tread on that sort of territory. I think basically what astronomers do is tell you the how, but not the why. And when you ask questions about the why the universe, then you get into the realms of where does God come into the picture. I think basically what we are doing is telling a story of how the universe formed from when it was a few fractions of a second old, and clearly it's going to be the sort of universe that we can exist in, otherwise we wouldn't be here. But I think it's my own opinion that, perhaps sadly, that astronomy has absolutely nothing to say about the existence or otherwise of God.
Okay, sir.
I think astronomers do have good evidence that the universe is expanding, contrary to what Patrick says. And I just wondered, people often ask the question, if the universe is expanding, what's it expanding into? What is the extent of the universe? And what is beyond that?
So you're asking what is beyond the universe?
We're back to what I said earlier, aren't we, though? Either the universe is finite or else it's not. If it's finite, then what's outside it? If it's infinite, you've got to imagine something that goes on forever. The same kind of argument. We just don't. We are several dimensions short.
It's not an allowable question.
Robert.
It's the wrong question.
Right, sorry. Can't ask. Yeah, absolutely. I think we probably came through a black hole, and anyway, I won't go into that. Yes, sir.
Hi, yes. We saw pictures earlier of stars being born. Was that how our sun was born, and how did the Earth how was the Earth formed?
Robin.
Yes, in fact, the picture I showed was a very good example of the sort of situation we think that our sun was born into. In other words, one of those gas clouds collapsing, condensing. Now, as it collapsed under its own gravity drawing it together, it also started to rotate, or the rotation started to increase, because it's something to do with the conservation of angular momentum. When you shrink something down, if it has even the slightest tendency to rotate, by the time you've shrunk it down a factor of 1,000,000, it's going around quite fast. And while the central ball of material was squeezing harder and harder, and just like pumping up a bicycle tire, making the interior hotter and hotter and igniting the nuclear fuels, the debris that was orbiting round the outside was, we don't know the exact details, but we think it was that debris that condensed into the planets. And when we look with the Hubble Space Telescope into the Orion Nebula, for example, we see these protostars with these disks of material around them.
Where is the Orion Nebula?
Well, actually, it's quite, that's about the one constellation I can recognize. If you go out in the early evening, you'll see the, the familiar belt.
Yes.
And down in the sword, in the middle of the sword, if you look with a pair of binoculars, you'll see a fuzzy patch. That's where stars are currently being born, about 1,000 light years away. Now, when we look with the Hubble there, we see these disks around these stars that are being born that seem to have about the right mass to form planets. So that's how we think planets are made. So we actually think planets are quite common, and in fact we've started to detect them around some relatively nearby stars.
And the process, of course it would be sensible, but I've never thought about it before. The process is carrying on and on and on and on.
Oh, yes.
One tends to think of oneself as the end product. Isn't that egocentric? But of course it's still going on and on.
Absolutely.
More questions, yeah.
I was just thinking about the black holes. If you can put matter into it and it just seems to disappear, would we be able to put our own waste, like nuclear waste, into the black hole?
Could we use it as a dustbin? That's a good idea.
Well, you'd certainly never see it again. It would be
You'd be spaghetti by the time you got there. I don't think we'd like that, would we?
Well, I wouldn't mind doing that with nuclear fuel. It's better than putting it in the sea, for example, or
Yes.
in an exhausted mine. It would be an ideal dumping ground. However, the practicalities of getting it there and disposing of it and that's a big issue.
It is a problem.
I think there's something we ought to say about black holes. We've given the impression they're very dark and black, but in fact they generate some of the most luminous and brightest objects in the universe, and they are the most efficient sources of energy. If you drop material into a black hole, you can convert nearly half its mass into energy and make some very, very bright objects.
Robin, I've just noticed you have a tennis ball by your foot.
Oh, yes.
What is this?
This is my little demonstration of the speed of light, because we've been talking about distances in light years and so on. And in astronomy, we have this unique ability over every other science. We can look back in time, which nobody else can do, so we can see things the way they were. Not here, of course. But so the thing about light is it seems to go incredibly fast to us, 300,000 kilometers every second. On the scale of the universe, goes rather slowly. So the only way I can illustrate the speed of light is with this tennis ball, which I take to represent the size of the Earth.
Right.
got a piece of string that I've wound round 7.5 times. So here I am unwinding it, and that is just about the distance that I can stretch, excuse me, Monica, with my hand. And that, if this is a model of the Earth, this is the distance that light travels in 1 second, almost the distance to the moon. So if you like, that is a distance of 1 light second, or a look back time of 1 light second. Now, everybody knows how many seconds in a year.
Isn't that brilliant?
After all, if Earth is there and
Yes.
Sun is there,
Yes.
nearest star is going to be 4 miles away. What that is in metric, I neither know nor care.
Patrick, we are with you there. Yes, madam.
Talking about all these vast distances, how far can we travel in space?
We can't even travel as far
Monica.
as the moon at the moment. Patrick was talking about putting people back on the moon. We don't actually have the technology developed to do that at the moment, although the technology is being developed.
Explain to me why that is, because they did it. So
yes,
why
I know
can't-
they did it, but you said yourself about the backup, the rescue, the contingency, which wasn't there. We're
Yes.
now more aware, perhaps, of risk and concepts like that. So although we have astronauts travelling in the space shuttle, we have the Russian cosmonauts in Mir, and trying to build the space station as the next step to interplanetary exploration, it's still a trying and testing phase. At the moment, we don't have people training to go on missions to Mars. We don't have people training on going to missions to the outer satellites of Jupiter.
Is that because
So-
there's no particular motive? It's not going to help the Cold War. It's not going to be economically productive for the human race. So we're spending our money elsewhere. Paul?
I think the reason for it is that we can travel by proxy. We can't take ourselves
we're
somewhere,
sending our machines.
but we
Yes.
send our machines.
Yeah, I
And
understand.
our machines have gone about as far as they can and still be within the solar system. We've gone beyond the most distant planet, beyond the planet Pluto.
So I took the question to mean, how far can we as people travel?
Yes,
Did you
absolutely.
mean we as sending machines or rockets? Or...
Well, also, how far is it theoretically possible for humans to travel?
Well, provided they've got the time, they can travel the distance. For example, our radio broadcasts, very early black and white pictures of Patrick or Esther, have travelled... possibly even mere radio broadcasts have gone perhaps 50 light years into space if they were broadcast 50 years ago. Not in these two cases, but old radio shows have gone 50 light years only. And that would be the absolute maximum that we could have gone if we'd started out 50 years ago. So the amount of space that we can explore and the amount of space that we can even influence by broadcasts or by sending machines is tiny, 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 tiny compared with the universe.
Right, madam.
What about time travel? Is it actually possible to go back in time at all?
Shall I take that one?
Yes, Mike.
It's an interesting speculation. I'll talk about time travel both ways because, you know, it would be nice to know which one can do, because it relates to your question about how far you can actually travel in space eventually. It is theoretically possible, and I think reputable scientists would agree, I hope, that you can in fact travel forwards in time if you wish, provided you go fast enough.
Into the future?
Into the future, if you wish. You can travel into the future if you can go fast enough. The furthest you can go, I reckon, is probably about 2 million years into the future. It would take you 33 years of your life, and you'd have to have a spaceship of several million tons.
And are we coming back?
Now, I'm sorry about that. You should have asked before you started the journey. So far as we know, it's not possible to travel backwards in time. There are some very good reasons why it's not possible. Basically, the so-called causality problem, which is a very popular one. I'm sure many people know this. Suppose you, and it goes something like this, and it's very difficult to refute. Suppose I build a time machine that allows me to go back in time. And so I build this machine, and I go back, and I kill my mother before I'm born.
Absolutely.
Okay? What happens? I couldn't have built the spaceship, because I wouldn't have been here. And this
You
sort of
turn
idea
into a black hole,
of causality
clearly,
makes it
yes.
very difficult to see
Yes.
how it would actually be possible to make a real time machine. You know, why aren't they here? Why don't we have all these problems and so on? There are certain very restricted conditions on which you might be able to do it, but it's...
Fascinating. We've got some more questions here.
I've always said that travelling backwards in time is one of the very few things that is really impossible. It's difficult to say things are out of the question, but I would say that travelling backwards in time is one of the very few cases where it simply cannot be done.
Right, yes, madam.
Apart from not knowing what happened just before the Big Bang, what other important things do we not yet know about the universe?
Practically everything. Now, I must say, you can't talk about what happened before the Big Bang, because if space, time, and matter came into existence at the same time, there wasn't a before. Work around that one.
Esther, I'm an idealist in this.
Yes.
I think it's absolutely marvellous that human beings, animals that survive for, what, 100 years at most, and are, what, 2 meters tall at most, and weigh such a small amount, have a brain in them so tiny, but can talk to one another, can make machines, can look up, can wonder, can imagine, can discipline themselves with their knowledge to understand anything about the universe. I think that's utterly marvellous. I think that although we are tiny, tiny in the universe, although we live such brief lives as a wink in the life of a star, yet I'm very proud to be a human being and a member of the human race in which we can even imagine what might go on.
So you refuse to be downhearted by what we don't know. Just time for a couple more. Yes, sir?
Someone said at the beginning that Comet Shoemaker-Levy might have hit the Earth rather than Jupiter. Has anyone worked out what would have happened? Would we still be here?
What, the comet that hit Jupiter? If it had hit us, where would we be now, Monica?
Oh, vaporised.
Vaporised. Look on the bright side. One more. Yes, sir.
Is it better to tell all the children in the world, including me, that God created the Earth instead of thinking that we all came from this kind of Big Bang?
Yes. Do you feel at all guilty?
I always feel, though, there are three things one should never discuss in public: football, politics, and religion.
Yes, you'd wipe out most of television, wouldn't you, if we did discuss it? Can I ask one last question? I would like to know from the members of the panel what question remains that you personally would like to answer. If God were here in the studio, what question would you put to God? Because you really are dying to know. Let me ask Mike.
Well, they're two. I'm allowed two.
Yes?
The first one would have to be why?
Why?
Just why?
Why creation?
Why creation,
Right.
if that were the case.
Yes.
And going back, I think it does make sense for people to scientifically question where the universe comes from. As I say, I don't think it impacts really on religious belief. Religious belief is another thing. And what you think is behind it in a vast scale or whatever is your own personal beliefs. But I think it makes a lot of sense that children should certainly be told what the scientific facts are as far as we've been able to understand them.
So your first question is why?
Why, right. And the second one is, look, why did you leave all this missing matter around? We know there's loads of stuff out there. We don't know what the hell it is. There's a lot of...
Missing matter?
A lot of material in the universe called missing matter. We know it's there because it's gravitational influence on the universe. 9/10 of the matter in the universe is of an unknown form.
We can't see it?
We can't see it. We only know it's there because of its gravitational interaction. I want to know what the earth that is.
So do I, now you bring the subject up. Robin.
Yes, well, my question, I'm afraid I can't claim originality on this one, but my question to God would be, what is the question I should be asking you? Because that is not quite as fatuous as it seems, because I think some of the questions that really bother us, like what's outside the universe, what came before, we will see when our understanding is a little bit deeper that these are not really questions to bother about at all.
They're based on our minds.
They're based on our inability to comprehend something that I'm confident that not far in the future we will comprehend. So I would say to God, what is the real question I should be asking?
I think that's cheating.
Then
Monica.
I would ask God, and I'm sure she would help me with her answer. I would say that astronomers and cosmologists are looking backwards, going back towards the Big Bang, trying to understand that, trying to unravel. I would like to look forwards. Where are we going? What's the future going to hold? How is our evolution going? as the sun evolves, as it changes the balance within the solar system, as our sun evolves towards a red giant and it changes the temperature of the Earth, it changes the temperature of Mars, what's going to happen to the solar system, what's going to happen to our sun, what's going to happen to our galaxy.
You sure you want to know?
Well, you know, I'm curious.
Yes, even if it's bad news. Paul?
Well, I like to ask why it all appears quite so arbitrary to us. It's quite complicated. And there are these different atoms, and there are 4 different kinds of forces, and there are electrons and protons, and they have the masses they do, and it all looks a bit like it was made of Lego, of different colours and chosen just for arbitrary reasons. And I would like God to explain what the subtle reasons were that it's made in the particular way that it is.
Perhaps one day we will discover that. Patrick?
I would like to ask a quite simple question. Is there really other intelligent life up there? Are we alone or are we not? Now, I say, somebody asked me a little while ago what I'd say if a flying saucer landed in my garden, a little green man came out, and what I'd say, good afternoon, tea or coffee? Please come with me to the nearest television studio.
Fascinating discussion. We've been talking about the universe as seen from here on Earth. What about the Earth seen from another planet? Well, a very lucky astronaut called Story Musgrave was sent out to mend a solar panel on the Hubble telescope. And the pictures he sent back were breathtaking.
And I'm looking above the telescope now and down onto the west coast of Australia. And so I'm 18,000 miles an hour, 25,000 feet per second at 370 statute miles, and there is absolutely nothing but a wide panoramic view of the Earth and the entire continent. From this altitude, you can see thousands of miles. I had never experienced that kind of scale, which I am not Superman, but when you feel the sort of the urge to stretch out and fly when there is nothing there before you. As a human experience, I would have to say that that was the crowning moment. Mission Control was stunned. All they could say was, the view, Story, the view.
Subject to the entire continent of Australia from here.
And it is quite extraordinary, isn't it? So maybe, while we've all been talking about the view from here on Earth, someone maybe on Europa has been looking down at us. And if so, let's hope he, she, or it enjoys that fantastic view. We'd like to thank all our guests in the studio for a fascinating glimpse into the universe. We'd like to thank you at home for joining us. Until next time, from everyone here in this particular tiny portion of the universe,